Hello, chemistry students. In this video, we'll be discussing percent yield, which is essentially a measurement in our efficiency of conversion of reactants to products. So we'll continue our discussion with stoichiometry rather, and you'll have to still do your stoichiometric calculations, but we'll just add an additional element, basically a ratio, a percentage. So in real life situations, we have to realize that not all of the reactants are converted completely to products. There's a lot of reasons for this incomplete conversion. You could have contamination, impure samples, side reactions, and just all around a lack of contact with the reactants. For example, if you're in a precipitation reaction, some of the ions might not come in contact to precipitate out of solution. So it's extremely difficult to get 100% yield. Typically, if you have 100% or more, it means that your sample is probably wet or is contaminated. So again, going from reactants to products, you're not always going to have 100% yield. So we have to do a measurement to see how good we are, how efficient this reaction was. So stoichiometry allows us to determine on paper what we should produce. That's why it's a theoretical yield. If everything worked out perfect, this is how much product I would produce. In lab, we don't always see the theoretical yield. In lab, we lose material. Again, we don't have complete conversion. There might be a contaminant or an impure sample. Whatever it is we recover or what we get in lab is what we actually yield. It's the actual yield. So basically, the ratio of these two times 100 is the percent yield, and it represents the efficiency of our technique in converting reactants to products. So you just have to remember actual over theoretical times 100 is my percent yield. So let's apply it to a stoichiometric problem. When 11.5 grams of carbon are allowed to react with 114.5 grams of copper 1 oxide, 87.4 grams of copper are obtained. Determine the percent yield. So right off the bat, we see that now there's three numbers. What do we start with? Well, they're telling you this is obtained, the 87.4 grams of copper. We see that the copper is the product. Obtained basically means this was my actual yield. A clue for this is saying determine the percent yield. So what we need to determine, because in lab I collected this amount of copper, what I need to do is use my stoichiometry to figure out what my theoretical yield was. But like before, as we observed in the other videos of limiting reactant calculations, this is a double stoich. I know it's a double stoich because they give me not the quantity of one reactant, but the quantity of two reactants. So what do? I'm going to start from, my grams of carbon, go to moles of carbon, and then from moles of carbon, go to moles of copper, and then from moles of copper, I can go to grams of copper. And how can I go from grams to moles of carbon? I'm going to use my molar mass. And then from moles of carbon to moles of copper, I see in 1 mole of carbon, there's 2 moles of copper. So I use my mole ratio that I've been using the whole time. And then from moles of copper to grams, again, using molar mass, grams per mole. But I don't do that for just one reactant. I do it for both. So I go from grams of copper 1 oxide to moles of copper 1 oxide to moles of copper to grams of copper, which again, in the other videos, we see that that last portion is the same in the double stoich. So there I have 115 grams of carbon How do I convert grams of carbon to moles? I use molar mass. I cancel out the unit of grams. Now I want to go from moles of carbon to moles of copper. How do I do that? I'm going to use my mole ratio. There's 1 mole of carbon per 2 moles of copper, so that cancels. And then I go from moles of copper to grams of copper, again using molar mass. I look at the periodic table. In 1 mole of copper, there's 63.5 grams. And then I just repeat in the double stoich. So now I go from the 114 grams of copper 1 oxide. I use its molar mass and convert the grams to moles. I use the mole ratio of the copper 1 oxide with the copper to cancel out the unit of moles of copper 1 oxide. And again, this last portion is the same, converting the moles of copper to grams. So which is my theoretical yield? So just like our limiting reactant problems, we pick the smaller amount. So 101.7 grams is less than 122. So this is my theoretical yield. And then I also know that the carbon is in excess. And I also know that the copper 1 oxide is my limiting reactant. But what they're really asking you is, what was the efficiency of this reaction? What is the percent yield? So I have to plug that in. And we have to remember actual over theoretical times 100. We obtained the actual in lab. It was given in the problem. And we calculated the theoretical on paper using stoichiometry. So we put it in the ratio. The actual was the 87.4 grams, either obtained physically in lab or in the problem provided. And then the theoretical yield was given through stoichiometry times 100, which gives me an 85.9% yield. So I hope that makes sense. If you guys have any questions, let me know. And thanks for tuning in.